Okay, let's practice this row vector rule. So I want you to do this calculation, which you've actually done before in 1.4. 2, negative 3, 8, 0, minus 5, 2, 4, 7 equals question mark. I want you to use the row vector rule to sort this out. So pause the video and do so now. Pause, pause, pause. Work, work, work. Okay. So here's my answer. So I'm going to go this row times this column. So I get 8 minus 21. And then I get 32 plus 0. And then I get minus 20 plus 14. And this gives me minus 13, 32, minus 6. There you go. Okay, let's go back to 1.8 now. Let t of x, let's just say let t from Rn to Rm be linear. What happens when I take t and apply it to the 0 vector? Well, what do you think? All I know is that t is linear. I don't know anything else. What happens to the 0 vector? Well, I don't need to know anything more about t. In fact, I can just use the fact that, well, t of c times x is always equal to c times t of x. Okay, I'm going to use this. I will use this. Okay, this is in the definition of a linear transformation. So if I go t applied to the 0 vector, well, what is the 0 vector? Well, I can write that as the number 0 times, well, I can times the 0 vector. I guess you do it that way. Okay, with this equal sign here, I'm just trying to say if I take 0 times the 0 vector, okay, here I have the number 0, the real number 0. And here I have, a 0 vector, and then, some vector where all the entries are 0. Okay, so if I take 0 times 0 vector, that's the same. So if I go 0 times a 0 vector, that's the same thing as just the 0 vector, right? Okay, it's a weird thing, but it's a technique, right? Because now this 0 here is like the C sitting right there. So it can move out front. Oh, ho, ho, ho. 0 times t of 0. Okay, so this equal sign, to justify it, I'm using this equation. But now I have the real number 0 times some vector. I don't know what it is, but it doesn't matter, right? Because if I take 0 times a vector I always get the zero factor. So t of 0 is always 0 if t is linear. That's what I have demonstrated here.